Hi there, my name's Finn. I'm a flight instructor in the southeast of England, and welcome to this video. This one's all about estimating crosswind. Before we get into it, these videos that I do are all designed really for you guys. Maybe you're a PPL student and you're going through your course, and there's a lot to learn, there's a lot to pick up. And the whole idea is that there'll be a video here that hopefully covers something that you've heard in the waiting room of the flight school, or heard your instructor mention in passing, and you haven't quite had a chance to ask them to explain that. Or maybe you've got your PPL and you're off using the privileges of your license, having a great time flying around. I'm hoping to upload a bunch of videos that will help you develop to be a nice, safe pilot, to cover things about how to stay out of trouble, whether that be infringements or whether that be just talking about threat and error management and how that actually works as a private pilot. So this channel's hopefully, well, if that's for you, then brilliant. Tune in and let's get started talking about crosswind. So first off, I just want to define what even crosswind is. Essentially, it's the amount of wind that it's at 90 degrees to your direction. So if you're facing into the wind and the wind is coming from immediately in front of you, then you haven't got any crosswind at all. And if you've got wind coming from your side, then all of the wind is crosswind. And in the middle of that, some of the wind is crosswind and some of it ends up as headwind. It's measured in knots, and it can be quite important for safety. In fact, why is it important? There might be limits on how much crosswind your plane can cope with on takeoff or landing. And that's detailed in the POH. If you haven't really looked at your POH and you're early in your PPL course, then check out another video of mine that sort of walks you through how to go through the POH and find all the information. So maybe your aircraft has limits. Maybe they're soft limits. Maybe they're often to be defined as demonstrated crosswind, the maximum demonstrated crosswind. I'd use that as a fairly soft. I'd treat that number with respect. There's a reason that the manufacturers put that number in the POH, and it should be treated with respect. So yeah, maybe your aircraft's got limits. Maybe the school or club or company you're flying for, maybe they have limits as well. If they do, this will be detailed somewhere in the operations manual or some other specific rule book. So maybe that's important as well, to not break those limits, because if you do, then maybe if you have an accident doing that, you might get into trouble. And at some point, there's a limit. At some point, there will be too much crosswind to safely take off and land, and it would be unsafe to do so. So that's presumably quite important. And really, I'd recommend, if you're a PPL holder, that you have some sort of personal limit, knowing not just what the plane's capable of and not just what the airport or the company think is capable, but also what you are capable of. If you've flown loads and are really, really up to scratch and really well rehearsed in landing and taking off in crosswind, then maybe your limit will be quite high. But this limit should be fluid as well. So when you haven't flown for a long time, the last thing you should do is go and take off in a big howling crosswind. So that's what crosswind is and why it's important. Let's dig into it a little bit more. So how do we even calculate it? And that's really what this video is about. We need a few things first. First, we need the wind direction, and then we need the wind speed. And that makes up the wind. And you're probably quite used to hearing that because you hear it on the ATIS. If your airfield has ATIS, then it tells you what the wind is. Or it's also displayed on METARs. So even if your airfield doesn't have a METAR, then there will be one nearby that does. And you're also used to hearing air traffic control, even if you're flying from an airfield that's got Aerodrome Flight Information Service rather than ATC or an air-to-ground service. They'll often still use tell you what the wind is. And they'll say it in exactly the format we need, which is the wind direction and the wind speed. And then you can also, if you haven't got any of those, if you're just on a farm strip on your own, hopefully you've got a windsock somewhere, you can have a look at it, and normally you can work out how windy it is and what direction it's coming from with that. And it's a bit more rough and ready. Okay, let's get into this. Let's actually work out how to calculate the crosswind. We're going to first talk about how to do it on the ground. Maybe you could do this when you're preparing for your flight the night before. So the first thing we're going to talk about is the easiest, and this is just head to the POH. And in most POHs, there'll be a page that looks a little bit like this. And this is brilliant. Let's say, for example, we are using the northerly runway, so runway 36, and the wind is, let's say, 040 at 20 knots. So all I do is I head here, I go angle between wind direction and flight path. Well, if the runway is 360, and the wind's at 040, then that's 40 degrees. So somewhere on this line, and 20 knots, if I just draw a dot here, and in fact, even better, if I draw the line with my very smooth hand down here, then it's telling me that I've got what? 13 knots of crosswind. And there you go. That's worked out just by drawing a couple of lines on a bit of paper. Quite easy. So that's one way you can work out. Another thing you can do is take a look at your flight computer. Now let's look at this in a bit more detail. So I've got a basic flight computer that you will probably recognize here, and all I do is head down, get myself on the wind side, and get myself down here on the bit that's gridded. We're going to ignore the top bit here for now. All we're going to do, first things first, is we're going to put the wind in the top. So we said, let's use the same example. So first thing to do is get the wind in there, so 040 degrees. And then we said it was going to be 20 knots. So I'm going to get my big fat marker so it shows up nicely on the video, and put a mark there at 20 knots. Big dot there, hopefully you can see that. That's at 20. And then we're going to use the runway 360, so the northerly runway. So if I just spin this round here, so it's nicely on the north. And when I come down here, you can see, if I measure how many dots it is across to the crosswind dot there, then it's telling me that if I eyeball that, looks to be about the same, actually about 13 knots of crosswind. So that's another thing you can do. You can use your flight computer to work out the crosswind. Next up of things you can do is use mathematics, maybe get your calculator out. The formula is, well, let's show you how the formula is made actually, because this is going to form the basis of all of these calculations. So here's us on our runway heading to the north, and here's the wind coming at 040, 20 degrees. And actually, if you think about it, if I draw a line in here, this is what we're trying to work out. How much of this wind here is coming along in this direction? And if I draw another line here, what we can actually make is basically a bit of a triangle. A triangle is brilliant because once you've got a triangle, you can use some pretty simple maths to figure it out. Now, before you switch off, I appreciate that maths isn't always our strong point as pilots. So I'm going to dive into it a little bit. I'm going to dive into it and I'm going to show you how we can simplify it. But essentially, first off, all we need to know is that if we work out essentially the sine of this angle, and then times the wind velocity by that, it will give us the crosswind. So the crosswind, I've written the formula down here, equals the wind speed times the sine of this angle between the wind direction and the runway heading, which we said was 40 degrees. So if you get your calculator now and tap in sine 40 times the wind speed of 20 knots, that should give you something around, hopefully around 13 knots, which we just calculated already. Okay, so that's on the ground. We've got plenty of time, but how does this work in the air when we haven't got much time? How do I do that complicated formula? I don't want to reach out and be getting my flight computer out while I'm trying to fly. That's not going to be very easy. Oh, I don't want to have to get the POH thing out and draw lines on a thing every time. That's not going to be easy either. So what that means is we're going to have to rely on that formula. And in fact, we're going to have to do some mental maths. But I'm going to show you a way where we can simplify this down so much that you will be able to do it without even thinking about. So we have to rely on mental maths and we have to rely on this formula because this is how it works. And most of this, actually, I think we should be able to get. We're able to get the wind speed. That's quite easy to get. We don't need any maths to hear the wind speed. The example we've been using so far is 20 knots. So I've got my wind speed there. And we're pretty able to get the difference between the runway heading and the wind direction. That's quite easy. The hard bit is calculating what on earth sine is. So what we're going to do is look at how we can essentially calculate sine with our mental maths really quickly and really easily. So dive into maths a little bit, maths world. Here we go. This is a little portion, the first sort of 90 degrees of the sine wave or the sine curve. And you can see at 30 degrees sine, we're at about half, and about 60 degrees, it increases up to about 0.9 essentially, about 90%. So we're going to simplify this even further. So don't forget what we're doing here is we're trying to find a way to calculate sine really quickly and simply. So I've got a table up here of different values of sine, and you see here that 20 degrees off is about a third, and 30 degrees off is about half, 40 degrees off about 2/3, and 60 degrees is almost 90%. So what we're going to do is we can simplify that more. And in fact, I don't want to call it 90%. I'm basically going to call it 100%. And it's as good as all the way. And this is what I'm going to use to calculate this, because I can get my wind speed easily. I can get the difference in the angle easily, and then that can give me this fraction easily, and then I can do this maths really easily in my head. So let me show you how I remember what the value of sine is when I'm doing this. So here's my wristwatch. It's very expensive, made by a niche Japanese firm called Casio. And so let's talk about the calculation we were doing a second ago, where we were using runway 36, and the wind is coming from, that's not a very good 6, we're using 36, and the wind's coming from 40 degrees off. So we're trying to work out what the sine of 40 is. Well, if I go put 40 minutes, look at my wristwatch and think about what 40 minutes would be, it would sort of take the minute hand would be over here. And if you think about it, it would take up all of this amount of the watch. 2/3 of the watch. 2/3 of the watch is taken up by 40 minutes. And actually, this is exactly how we estimate what sine is. Because if I calculate it for a different value really quickly, let's say 30 degrees off, then I can pretend that's 30 minutes, and I know that's half of my watch face. So then I know the value of sine. Or let's say the wind is 60 degrees off. I think 60 degrees, that's 60 minutes. That would be all of this watch face. So that would basically be 100%. So all of the wind would be a crosswind. And this is how you can calculate really quickly that sine value, and thus how much crosswind you got. So let's show you that in action. Okay, so here's some examples. Let's roll through this. The first one, we're on runway 18 now. So the runway heading is 180. And now's the time to kind of actually forget about all the math stuff that I was explaining how this works. Let's just focus on doing it. So runway 180, the wind is 20 degrees between, coming from 20 degrees off. So I know that I'm trying to work out the sine of 20. If I go over to my watch here, I go 5, 10, 15, 20 minutes is there. Look at my watch, and that takes up, about a third of the watch face. So I can say that I've got about a third of the wind is crosswind. So about a third of 9 knots is 3 knots. So I've got 3 knots of crosswind. Okay, hopefully this is starting to make some sense. Let's use another example. So let's say we're on a westerly runway 270. The wind is coming from 210 degrees. That's a really good 2 there. Wind is coming from 210 degrees. So I think you'd agree that's 60 degrees off. And if I look at my watch face this time, then 60 degrees is, well, it's all the watch face, isn't it? We said before. So all of this 9 knots is crosswind. So I know that the crosswind in this takeoff or landing is 9 knots. Okay, cool. Let's look at a similar example to what we were looking at earlier as well, where we were looking at runway 36. So northerly runway, and wind from the left now by about 30 degrees. So if I go back to my watch face here, 30 minutes would take up about half of the clock face. So half of 20 is 10 knots. That means on this takeoff or landing, I've got a 10 knot crosswind. Okay, so that is how you can calculate the crosswind component really, really quickly in your head. You don't even need to have a watch on you, because you can quite easily imagine this in front of you. So my challenge to you is to find out the crosswind limits of your plane or your flight school or your company or your airport, and then maybe also your personal limits. Think about what your personal limits are. So when you find your limits, these are the places you might find them. If you're unsure, just ask a flight instructor. And then my challenge is for you to calculate the crosswind on every takeoff and landing. When they pass you the wind, when they clear you to land or clear you to take off, think about what that actually means. You don't have to immediately think about it. Just put the wind speed and direction in your head, apply to air traffic control, and then think about what that actually means for you. Those are my challenges for you. If that doesn't make sense, let me know down in the comments or email me flywithfinn@gmail.com or follow me on Instagram to see lots of hilarious photos of me at various different airports. And good luck and happy flying.